Welcome to our viewers. Again, thank you for joining us for the webinar today, Increase Flexibility and Decrease TCO with Hyperconverged Splunk Deployments. My name is Jennifer. I'm with Cloudian Marketing, and I will be your host. Joining us is Tom Nagelmeyer. He's VMware Product Marketing. Welcome, Tom.
Morning, everyone.
And then we also have Amit Rolani, Director of Tech Alliances with Cloudian. Welcome.
Thank you, Jen. Welcome, everybody. Good morning, good evening, good afternoon, wherever you are.
So again, before we begin, I wanted to point out to those that had just joined that we'll be taking questions at the end. So please enter the questions that arise in the question tab at the bottom of your screen. So with that, I am going to be passing it off to Tom.
Thanks, Jen. Let's go ahead and get started with the key challenges that organizations are facing today. So IT has taken on a more prominent role in companies than ever before, becoming a critical enabler of the delivery of goods and services, for-profit, nonprofit, government, you name it. And the global pandemic has only accelerated these trends. And IT has struggled to adapt to these challenges, often failing to keep up with the needs of the business. And without digital transformation, organizations risk being left behind. And what's proven to be the main bottleneck to innovation? Well, we think that there are the three causes you see on this slide here. High cost, purpose-built hardware, and the processes to manage that infrastructure, the expansion of infrastructure from the core data center to the public cloud, as well as the proliferation of next-generation applications. And in addition, these trends are only growing even more. Cloud computing growth is accelerating, and organizations increasingly use both on-premises data centers and public cloud, and they selectively run their applications in the environment, which provides the greatest benefit. Applications increasingly migrate between on-prem and the public cloud. And however, this can lead to organizational inefficiencies. Many IT organizations create separate infrastructure teams to help manage the complexity. And IT also struggles to move applications between clouds, and attempts often stall to numerous technical challenges. And finally, the very applications running on the infrastructure are changing. Traditional monolithic applications are giving way to microservices that have their own needs, and IT can't address the needs of these new applications with the infrastructure on hand today. So let's talk about that a little bit more. Monolithic architectures, where every piece of the application is intertwined, from I/O to data processing to rendering, are the traditional approach to application development and packaging. Everything is in a single package, which is a larger code base that is more difficult to maintain and debug. It is a challenge to separate and work on individual components. Development, test, and production environments are seldom identical, various operating systems and hardware builds. Microservices, or independent standalone capabilities designed as an executable or process, are a new concept quickly displacing these monolithic applications, and for good reason. Microservices offer organizations resource-efficient scalability, faster development cycles and time to market, and they're less expensive to build and maintain. Instead of spinning up an entirely new instance of an application, microservices offer organizations a way to scale only the in-demand portion of an app. And they're also designed to do only one thing, so they consist of a relatively small amount of code and have fewer dependencies, which reduces development cycles. And therefore, they require much less time to build, test, and deploy, and avoid downtime during updates. However, microservices bring their own challenges to the data center. The benefits of adopting them require changes to the status quo. For instance, due to their architecture, microservices pull the complexity out of the application and place it on other systems. They need robust management and orchestration to deal with the complexity of hundreds or thousands of microservices replacing a single application. As an example of the complexity to be managed, each microservice can have its own data. One microservice can use traditional relational databases, while others could use others, such as a NoSQL database. And they're most commonly run in containers, and containers were originally designed for stateless applications. And while there's a clear desire to run modern stateful services such as object storage and self-managed infrastructure, modern stateful services, including object storage, present unique requirements for IT infrastructure. Shifting to a cloud operating model requires collaboration between developers and IT operators. Developers are accustomed to consuming cloud resources via standard APIs and in a self-service manner in the public cloud, unlike a traditional on-prem IT environment, which typically uses a corporate ticketing system. As organizations look to build out their private clouds, They want to replicate the public cloud experience so that developers and IT admins can easily provision and scale object storage on demand while maintaining granular visibility of storage capacity consumed. A hybrid cloud-ready, software-defined storage platform sets a good foundation for enabling such operating model across clouds. And for IT operators specifically, they see the benefits of having a single storage platform for modern and traditional apps. Proliferation of IT stacks leads to poor productivity and increased security risks. Rather than deploying modern stateful services on bare metal to create another infrastructure silo, IT admins are looking to unify the storage and data for modern and traditional apps on a single, proven, software-defined platform that meets the infrastructure requirements in terms of security, availability, and performance for various types of applications, while reducing infrastructure complexity. And for executives, with uncertainties in the global economy, IT executives are further pressed to do more in the most economical way possible. This is typically a concern when executives get $1 million bill from their public cloud vendor and when public cloud costs become unmanageable. Now back to Amit.
Thank you, Tom. And another key challenge that we want to address today is specifically going towards the topic that we are going to cover around the Splunk use case, right? So as Tom mentioned, a lot of this comes down to legacy architecture versus movement towards a cloud or a hybrid cloud or cloud native applications and cloud native way of doing things. A challenge with the classic architecture, specifically in the Splunk case, is the way the system gets architected with hot data as well as warm buckets coming into play. So in the legacy way of doing things at Splunk, you're talking about indexer processing and storage being tied together closely. This was very prevalent in not just Splunk, but also a lot of the architectures that were developed and proliferated, let's say in the late 2000s, early 2010s, where you wanted to co-locate data and storage as close to each other so that you were bringing the data to the processing unit. Well, the challenge with that is you're tying the scalability of the data with the scalability of your processing units. As you're trying to scale to accommodating the explosion of data, you are adding processing units, whether you need it or not. And that is a real challenge. So you are putting in a lot of resources where you may not need to put in resources, specifically in the case of Splunk. And of course, in the Splunk case, where you talk about the indexers, a failure of the processing unit in the indexer would also mean that your storage has failed, because you're really talking about an indexer server which has a lot of storage capacity built in. So if your processor has failed, you're obviously going to have to replace that. And guess what? In that case, you're going to have to rebuild the storage, the disk, that could require days worth of rebuild processing and downtime, which impact processing as well as the search operation that are business critical to you. And then finally, as you're scaling your data infrastructure, whether it's for regulatory compliance or you are looking at more analytics requirements, the more data, the better results. We all know that. You start to run into a huge amount of limitations with the legacy architecture and infrastructure, and could you scale to petabytes range? Maybe in the low petabyte, but as soon as you're talking about storing data in the years, it becomes a challenge. So a new way of doing architecture or architecting systems, which is more cloud native, which is how things are done in the cloud, is required, right? This is not just from a cost perspective. Cost is definitely a big part of this, but it's also from being able to scale and do things in the manner where it's a collaborative world, and it's a way of the cloud. So what we're going to talk to you guys about is that new solution. So here we are talking about Splunk SmartStore, which is their next gen architecture running with Cloudian HyperStore on VMware's data persistent platform. Now we will introduce each of these components a little more in detail in the back end of this webinar, but I do want to just stage it right up front. What is this new solution and why is it important, right? So the solution that we're talking about is Splunk's next generation architecture, Splunk SmartStore, running on VMware's VCF, vCloud Foundation, with Cloudian running in the DPP format. Now, in the traditional method of Splunk architectures, you're talking about an indexer hardware which has CPUs as well as storage, performance storage, running directly on a server unit, and anything that is a cold tier gets pushed off into a NAS or a SAN kind of environment. Well, with Splunk SmartStore, this whole architecture was actually built for what is the Splunk cloud. It's the same as the Splunk cloud, and what customers started seeing is that's a more efficient way of doing it. It not only reduces their cost, but it's also a better way of doing it. So they started demanding that, and Splunk brought this to on-prem environment. Now with Cloudian, you get a massively scalable tier of object storage that runs directly behind Splunk. And what this means is now the indexers just need to be your processing units and a very small sliver of the hot data. Now, this is the data that's currently under processing, and anything that goes beyond the first, let's say, 3 to 7 days worth of data can get now pushed onto the warm tier on Cloudian and scale infinitely. All of this now is available to you with in a hyper-converged environment with VMware's vCloud Foundation running data persistent platform as the base of this architecture. How is that possible? Well, it is because Cloudian has partnered with VMware, and now we are part of the vCloud Foundation data persistent platform and can be directly run on the vCloud Foundation in a seamless manner. The benefits of this are obvious. You get ease of management from having a hyper-converged architecture. With Splunk SmartStore and Cloudian, you're talking about separation of compute and storage. The hot buckets reside on the block storage itself with vSAN, and the warm buckets can go into HyperStore object storage running again on the data persistent platform. This is efficient, it is secure, and it's infinitely scalable. And obviously, right, with object storage and the benefits that come with it, you're talking about one namespace for the entire solution that's searchable across the entire data set. You are getting not just cost efficiency, but also efficiency of your infrastructure and architecture. From a cost perspective, you're really talking about a huge TCO saving of achieving more than 44% of cost savings over 3 years' time. I mean, we've done the analysis along with VMware, and there's a white paper that you can actually download from the Cloudian website, which gets into the details of the components of this TCO analysis. We're talking about huge capex savings, which can be quantified by the amount of hardware that you're going to save on the processing side, which is not required now when you're scaling up storage only. But you're also going to save hardware on the need for cold storage in the Splunk legacy architecture, and that's a storage reduction, right? Capacity optimized hardware vSAN Direct really helps in reducing the capex here as well. And from an operational perspective, hardware and software support costs get reduced because you're now running on a hyper-converged architecture. Administration time is reduced, the complexity is reduced, and overall, this actually makes it more efficient for you to work the whole system. And of course, there is unquantified savings in this, which we are not even putting in our analysis. It's all about consolidation of workloads. It's all about leveraging skills across different aspects of the architecture, and the space reduction in the infrastructure will also reduce to will also lead to power and cooling savings, which do not get accommodated in the 44% cost savings that we're talking about. So it is a significant change. It is something that is the next generation of doing things, not just for Splunk, but we're going to focus on Splunk architecture today. And with that, what I'd like to do is let's get into the details of what the data persistent platform is, and then we'll get into the back end of how Cloudian actually also can help you with this. Tom, do you want to take that part up?
Will do. Thanks, Amit.
Yeah.
All right. So before we get into the data persistence platform, let's talk a little bit about VMware's hyper-converged infrastructure. And really, VMware has decided that strategically we need to move in a direction to be the platform that uniquely connects developers and operators, so that developers can self-service the infrastructure they need instead of relying on a corporate ticketing system, so that they can get access instantly instead of waiting days or even weeks for their infrastructure to be provisioned. And on the operator side, providing them the visibility into what's going on with their infrastructure, the applications running on it, delivering the availability and security that enterprises require, as well as the high performance infrastructure that developers are used to, and uniquely connecting that for both traditional monolithic applications as well as cloud native, and providing all of the key capabilities required to run these applications. So let's start with hyper-converged infrastructure. What is it? It all starts with the hyper-converged infrastructure taking a new simple approach by converting compute and storage resources on industry standard x86 servers with unified management software. HCI uses simplified workflows and a high degree of automation to accelerate storage operations. And here are a few ways that HCI can deliver a 259% ROI over 5 years. First is it's lowering those upfront costs, which with HCI, organizations need only procure the storage required today. They use industry standard storage components that cost less than the equivalent storage in proprietary hardware. And server-based storage eliminates the need for costly storage networking, fiber channel, instead relying on Ethernet. The software provides data services that often require expensive hardware, such as self-encrypting drives or SEDs. There's also less storage capacity required, as HCI can scale incrementally with just one node at a time at a fraction of the cost of a traditional storage array. And it can scale up to 64 nodes with multi-petabytes of storage as needed. It also eliminates certain manual processes that come with legacy arrays. HCI eliminates LUN provisioning and instead replaces it with a simplified workflow to assign a storage policy to a VM or a virtual machine disk, which can be completed in just minutes. And with many other storage operations accelerated with HCI, on average, our customers report savings of around 51% less time on routine operations. And HCI, because it's server-based, uses less real estate than traditional storage and a fraction of the energy. And so vSAN is our approach to hyper-converged infrastructure. Built from the ground up for vSphere virtual machines, it abstracts and aggregates locally attached disks in a vSphere cluster to create a storage solution that can be provisioned and managed from vCenter and the vSphere web client, all tools that IT admins know and are familiar with today. Industry standard components are used with direct attached storage devices, from spinning disks to SSDs to the latest NVMe technology. It integrates with the entire VMware stack and includes key features like vMotion, HA, DRS, and more. Storage provisioning and day-to-day management of storage SLAs can all be controlled through policies that can be set and modified on the fly. And it delivers the enterprise-class features, scale, and performance, making it an ideal storage platform for VMs and containers. So let's talk about how VMware hyper-converged infrastructure can accelerate operations for developers. Developers that are using containers don't want to worry about the infrastructure. They just want to scale it on demand. and containerized applications that require persistent storage can be deployed by the Kubernetes admin or developers without the need to understand the underlying storage. vSAN administrators simply associate storage policies to Kubernetes storage classes. The on-demand provisioning of these persistent volumes through Kubernetes would be via the use of these storage classes. And so let's see what this looks like. For an example, a Kubernetes cluster, which consists of a collection of containers, may need persistent storage. And below the cluster, we have the vSphere and the vSAN stack, which serves up those VMs, and VMDKs that provide the basis of the persistent volumes for the container. The vCenter server for the environment serves up a cloud-native storage control plane, which interfaces with the container storage interface, or the CSI, which is a part of the Kubernetes cluster. As a result, vSAN presents this storage as a first-class disk in the vCenter UI for easy management and troubleshooting. Storage policy-based management allows for prescriptive assignment of performance and resilience outcomes for the persistent volumes and their associated storage class. Using the software you already know, it's clear that vSAN provides a seamless experience for introducing container-based workloads into the environment. Admins, however, still want to maintain control over the infrastructure. For instance, they want complete lifecycle management of storage for containers, from provisioning to ongoing operations, including visibility into storage consumed by containers, capacity used, health and performance information, and compliance checks and remediation. Container volumes need the same enterprise-grade storage features found in vSAN for traditional VMs, dedupe and compression, encryption and quality of service, among others. vSAN provides admins everything they need to oversee the storage used by containers. For instance, within the UI, shown here in green, vSAN supports the ability to view multiple container orchestrators' persistent volumes at the same time. And it also provides rich feature filtering capabilities to quickly find and sort container volumes. Meanwhile, within the UI, the admin gains granular visibility into each container volume on par with virtual machines. These capabilities help quickly troubleshoot and remediate any support requests from developers and lead to much faster resolution times. So they can gain direct access to volume properties, see where each volume is placed in the data store, and have complete visibility into both block and file storage, and object with the data persistence platform, and complete health information for each persistent volume. Along with the vSphere CSI driver's ability to dynamically provision read-write once for vSAN block volumes for persistent storage, it also has the ability to dynamically provision read-write many vSAN file shares for persistent storage. The ability to dynamically provision read-write many volumes allows the resulting volume to be shared by multiple Kubernetes pods, a much sought-after feature. Here we have a platform that can provision both block and file volumes, as well as provision both read-write once and read-write many volumes for containerized applications that require persistent storage. And while the protocol for these read-write many volumes in Kubernetes is NFS, vSAN File Services also supports SMB file shares for traditional applications as well. Now, let's introduce the data persistence platform. Modern stateful services such as object storage, NoSQL databases, and event streaming services have become critical application components that provide data persistence for stateful applications. Running modern stateful services on-prem with traditional IT management model or in self-managed clouds brings new infrastructure requirements. Modern stateful services are designed in shared nothing architectures and have data services such as replication and encryption natively built in. They don't rely on the underlying infrastructure to perform these data services. Deploying such modern distributed systems optimally requires rethinking storage assumptions about what data services need to be provided. An IT operator should be able to quickly respond to developer needs and deploy modern stateful services easily without having to sweat the details about those services. IT operators should have visibility into the health and capacity consumption of modern stateful services, as well as insights into how infrastructure operations such as planned maintenance and lifecycle management will impact the availability of modern stateful services. And so the VMware vSAN Data Persistence Platform provides a framework for these stateful service providers to build deep integration with the underlying virtual infrastructure, leveraging the Kubernetes operator method and vSphere pod service, allowing you to run stateful applications with lower TCO and simplified operations and management. Now let's talk about some of the capabilities. First is VMware Integrated Service Monitoring. Modern stateful service providers can build service-dedicated dashboards in vCenter, offering a seamless experience for IT operators to maintain manage modern stateful services without having to leave vSphere. vSAN already offers rich health and capacity monitoring for VMs and container volumes. The granular monitoring capabilities will be extended to these modern stateful services to aid users in capacity planning and troubleshooting service issues. Specifically, any volumes provisioned and space consumed by the data persistence platform are shown under the partner service and can be linked back to the service-dedicated dashboards in vCenter. This union of services helps align developers and IT operators to consumption and uptime. It also provides service-aware infrastructure operations. For planned infrastructure operations, such as maintenance and lifecycle management, the vSAN data persistence platform ensures that modern stateful service is aware of the upcoming infrastructure operations and can coordinate activities with the infrastructure changes. And finally, vSAN direct configuration. With vSAN direct configuration, the data persistence platform provides an alternative storage option for modern stateful services to interface directly with the underlying direct attached storage for optimized I/O and storage efficiency. You can configure data services in vSAN based on their application needs. And together with our partners, such as Cloudian, we are modernizing how enterprises deliver and consume stateful services at scale with VMware Cloud Foundation with Tanzu. First, the first benefit of this approach is lower TCO. IT admins will be able to run modern stateful services with lower TCO by leveraging replication in the modern stateful service layer, by standardizing the deployment and management of modern stateful services, and consolidating both traditional workloads and stateful services on the same platform to eliminate infrastructure silos and leverage common skills and training. So next is to increase velocity. IT admins can deploy and enable a new stateful service for their application teams with a simple workflow right within vCenter. You can meet the needs of an application team rapidly without going into the details of the stateful services. Developers will be able to dynamically provision and scale modern stateful services based on their application needs in a self-service manner, which greatly reduces time to market for their apps and accelerates innovation. And finally, simplifying operations. Stateful services powered by the data persistence platform are now fully integrated with vSphere Day 2 workflow. Admins can manage stateful services as if they were VMs. Developers can provision and scale stateful services instances with Kubernetes APIs, just as how they would provision and scale Kubernetes clusters, vSphere pods, or persistent volumes on Cloud Foundation. Now, let's take a look at object storage. I'm sure you've heard of AWS S3, which is the object storage service on AWS and is one of the earliest and most popular services. And why is object storage popular for modern apps? Developers need to go fast when it comes to application development, and they want to use the self-service model that object storage offers. With object storage, developers can easily get the storage endpoint without having to go through a ticket-based mechanism for mount points. The standardization on AWS S3 as the de facto protocol accelerated the adoption of object storage. It's distributed and scaled out by design, making it a great fit for modern apps, which also tend to be distributed. Developers can easily scale storage with their application needs. Object storage is ideal for unstructured data such as video, photos, and logs, making it a good fit for a wide range of use cases, which we can talk about later. Why would you run object storage on-prem? Using public cloud services is like staying in a hotel. It's simple, agile, but it can be expensive. We are seeing some customers move those workloads on-prem as a result. Next is data gravity. It's important to move apps and services as close to the data as possible for performance. And data sovereignty due to security and compliance requirements. And finally, data protection. Other than for modern app development, object storage can also be used as a backup target for traditional apps that have been in the customer's data centers for a long time. Now, how do I actually use this thing on VMware Cloud Foundation with Tanzu? Enabling a third-party Kubernetes operator and plugin for the data persistence platform is as easy as a few clicks in the vCenter server user interface. The vSAN data persistence platform takes care of the rest, spawning the relevant third-party operator and creating the necessary container storage classes and vSAN storage policies. The UI plugin, an optional offering, is what is used to expose the monitoring and management details of the application. I'm just going to build this slide out. There we go. So the data persistence platform supports two deployment options for modern stateful services, including object storage. The first is standard vSAN, consolidating traditional and modern apps with optimal storage efficiency. This option provides a fast and convenient way to get started with running modern stateful services on vSAN. By choosing the vSAN shared nothing architecture storage policy, customers can leverage the availability features that come with modern stateful services and have replication turned off in the vSAN layer for minimum storage overhead and space savings. This option is ideal for customers who want to run modern stateful services alongside traditional apps on the same vSAN cluster or leverage general purpose infrastructure for modern stateful services with various workload characteristics. And the second option is vSAN direct configuration, which is dedicated hardware with optimal storage efficiency and near bare metal performance. vSAN direct configuration allows modern stateful services to leverage the availability, efficiency, and security features built into the modern stateful service layer, and to have direct access to the underlying direct attached hardware for optimal storage efficiency and near bare metal performance. It's ideal for purpose-built deployments of certain stateful services where the underlying hardware can be optimized for workload requirements. And so, again, when you would consider using this option would be a purpose-built deployment for a modern stateful service. And so primary use cases might be capacity optimized object storage for archive or infrequently accessed data, or performance optimized object storage for performance sensitive apps such as analytics, big data, or AI ML. Both options enable unified management of storage for traditional and modern apps through vCenter with granular health and capacity monitoring, providing a faster path to app modernization, better alignment between developers and IT admins, and reduced operational risk and increased efficiency. And finally, how to get the data persistence platform and partner services. Let's look at the different options and when those options will be available. First of all, you'll need to get the partner software, in this case, Cloudian HyperStore. And they're not part of the VMware offering, but for the VMware portion of the stack, there are two options. The first option is to get the full stack all at once with VMware Cloud Foundation with Tanzu. This is the recommended way to get the data persistence platform and how we believe most customers will consume the platform, because with a similar price tag, other than platform capabilities, you can also benefit from the fully automated lifecycle management and rapid infrastructure deployment at scale that are uniquely available in VMware Cloud Foundation. Second option is to build your own VMware stack that's required to run the data persistence platform and partner services. Since data persistence platform provisions stateful services instances as vSphere pods, also known as pod VMs, you would need to acquire vSphere Enterprise Plus, Tanzu Standard, and NSXT. In addition, the data persistence platform comes as a vSAN feature, and vSAN Enterprise or above is required. All right, back to you, Amit, for the Cloudian HyperStore deep dive.
Thank you, Tom. And yeah, folks, let's get a little bit into the details of what Cloudian HyperStore is. For those of you who are not completely familiar with HyperStore, we are an on-prem S3 compatible object storage. Our claim to fame is that we are the most S3 compatible object storage in the marketplace today. We are the only ones that are built natively on the S3 API. No translation layers, no gateways, and none of those bottlenecks that come with some of our competitors in the marketplace. And of course, customers really like what they get with Cloudian. Don't take our word for it. Look at all the rewards and the accolades that Cloudian has been getting over the last few years. And if you look at the bottom left, Cloudian has been the Gartner's Peer Insight Customer Choice Award for the last 2 years in the running. We are the only object storage vendor to have gotten this back-to-back. And on the critical capabilities of what is important in an object storage system and what customers look for, Gartner has been rating Cloudian as the #1 object storage in the landscape for the last couple of years consistently. Right. So what are we? We are an enterprise software-defined object storage system that runs on premises in your data center behind your firewall. We enable the hybrid cloud use case for storage, data storage, because we also give customers the whole application mobility and seamless deployment of application on-prem or in the public cloud, because we talk the same language as the cloud. With Cloudian, customers can start small as a 3-node deployment and scale to hundreds of petabytes. We have customers that run Cloudian in the 200 to 300 petabyte range. And all of this is based on simple modular scalability by adding one node at a time as required and scaling into hundreds and thousands of nodes. I already talked about the hybrid and multi-cloud ready nature. And with the whole integration of Cloudian into the VMware vSAN Cloud Foundation, we are now bringing the whole hybrid cloud story to fore, right? Cloudian is now able to run on proven VMware hyper-converged architecture. The way that Cloudian is enabled in this format is through running in container pods on the vSAN data persistent platform. And this gives customers a simplified way of getting Cloudian up and running in their existing infrastructure or in a modern infrastructure setup, supporting giving native support for modern applications, containerized applications, and being able to be the persistent storage layer for not just modern, but also traditional applications that may be running in their networks. Here's a logical view of HyperStore running in the Tanzu VCF context. The entire architecture is based on the modern containerized architecture. It is Kubernetes enabled. Customers can now avail of the same scalable platform to implement use cases like Splunk, which is what we introduced a little earlier in this webinar, in a hyper-converged platform, in a modern platform. But it's not just the Splunk use case, right? With Cloudian running in the VCF environment, you are able to not just support modern applications, you're also able to support any kind of traditional applications, whether it's being able to do data protection for your applications running in the same context, or it is running analytical applications on a more performant tier, as well as being able to be the repository for your media files, your video files, any kind of unstructured data can all go into the same platform. So it's literally your database, sorry, not your database, your data lake coming in an HCI environment to you with ease of management. Right. I touched upon this a little bit. The whole premise of this is grow as you need. You can grow your storage infrastructure needs one unit at a time. It is simple to set up and manage, and performance grows as you add nodes in a completely linear model. All of this comes in a single global namespace. And your whole environment is searchable, scalable, without any issues. And all of this is proven in deployments worldwide. And I would be doing disservice if I don't mention the military-grade security that comes with Cloudian. Now, Cloudian is on-prem storage, and we have focused on making this particular storage system completely secure. One of the major use cases of hybrid cloud, or having an on-prem premises presence for your data, is data security, it is data resiliency, and it is the requirements for a lot of enterprise customers to ensure that they can they can adhere to a lot of the regulatory requirements from a security and privacy concerns on the data. To that effect, Cloudian is a hardened storage system. We support features like secure shell, integrated firewall, access controls, and a host of encryption methodologies that come native with HyperStore. We are certified by a number of governmental agencies for things like common criteria, FIPS, SEC, CFTC, FINRA, and NIST. And we have one of the best implementations of object lock or data immutability inbuilt into the platform. With data immutability, customers are able to also provision their data and protect it against threats like ransomware, which is one of the most immediate threat to a lot of enterprises in the last couple of years that we've been hearing of. So if there is a security requirement and if there is need to make sure your data is secure, Cloudian is the platform for data storage for you. And I do want to leave you with some of the unique advantages because of which customers select Cloudian. It has the highest S3 compatibility. We have modular scalability all the way into exabytes. Multi-tenancy, billing, QoS, everything is inbuilt for service providers, customers, as well as for large enterprise customers, which want to offer storage services across different departments, but want to make sure that there's separation between the data stored and this. Encryption, worm, role-based access controls, and identity management all inbuilt into the system. Built-in data protection, whether it's replication or erasure coding, and giving you high data durability for your data stored in Cloudian. All of this comes with the native advantages of object storage, where you have metadata, custom metadata, and able to do integrated searches and data analytics all in the same platform. So with that, I'm going to point you guys to some additional resources that you can look at for Cloudian HyperStore, how we integrate with the VCF platform, as well as how we enable use cases like Splunk SmartStore, as well as a lot of our other use cases on our website. And Jen, we're done with the presentation part of the webinar with this.
Perfect. Excellent. I would like to thank Tom and Amit for their time today. So without further ado, we'll move on to Q&A. Our first question is, what are some of the other use cases that an S3 compatible object storage is useful for?
Great. So actually that's continuing in the vein of my presentation. So we talked about the Splunk SmartStore use case, but really object storage system is your cloud storage system. And as we've seen, AWS S3 is the gold standard of object storage systems out there, and it's a public cloud. That's one of the main reasons why AWS has been as successful as it has been. And AWS S3 has proven out all the use cases that are possible to use S3 with, right? And what you're talking about is any and almost all kind of data storage applications that can use an S3 object storage. Now, these include, and not limited to, and I'm talking from a Cloudian perspective, we've seen a lot of our customers use Cloudian for data protection. It is either it's your traditional IT applications or it's your modern applications, being able to back up your containerized applications, stateful applications, and the data that it generates onto a persistent data platform like HyperStore is a key use case, right? Being able to back up your VMs and all kinds of even NAS data, being the data lake or the data repository for warm data in big data in Splunk. We talked about that. But also Hadoop has been some of the use cases that our customers use for. Analytics, right? In fact, the whole capability of being able to do custom metadata tagging while storing data in your object storage system makes it not just searchable, but also capable of doing quick analytics on your data. Repository for unstructured data like media, video, audio files is pretty standard, and pretty much any kind of cloud native applications, anything that's been written for the cloud, you can rest assured that S3 on-prem HyperStore is a good fit for those kind of applications as well. So in a nutshell, pretty much most of your use cases on the unstructured data side, and on the side of anything that you need from a scalability perspective. What object storage today is not great for, and it's not that it cannot be used, but you should probably look at something else, is for high IOPS use cases where you really need very fast performances. For that, you have your Pure systems and your NetApps filers. But for anything, pretty much all of 80% of the rest of your use cases, HyperStore would be a great fit for those use cases.
Perfect. Thanks, Amit. Our next question is, how many VMware customers are running cloud native applications on vSAN?
Sure, I'll take that. That's a great question. And so what we have seen in our customer base, we surveyed last year hundreds of vSAN customers, and what we have found is that cloud native applications are actually one of the top 5 workloads being run on vSAN. I believe it's about 35% of our customers are running cloud native apps on vSAN today, for many of the reasons that I talked about during the presentation. It's the ability to run both traditional and cloud native apps on the same infrastructure. Our deep integration with Kubernetes, we announced that in March of last year. Integrating that and making it easy both for developers to access the infrastructure as well as the IT admin to manage it. And we know from our research too that when organizations choose HCI for cloud native applications, that they're choosing VMware over other HCI vendors in the market. So it's something that we believe we have a differentiated feature set for. And our partnerships, particularly with Cloudian, with the data persistence platform, is just another reason why customers would choose HCI, VMware HCI, for these workloads.
Perfect. Thanks, Tom, so much. We do have another question. What are the deployment options for Cloudian?
Thank you. Actually, I should have had a slide on that. I typically do. So Cloudian is a software-defined storage. Pretty much the deployment options are as the customer requires, right? So we sell as a subscription software. It runs on any x86-based hardware out there in the marketplace. We do have a consumption model available through VMware's VCP program. We are a part of the VCP program that VMware has. So if anybody wants to have a consumption model of Cloudian, that would be one way to do it. And then, of course, our latest deployment options are on the modern application side. So containerized persistent storage for VMware Tanzu, and other Kubernetes-based distributions out there is another option. We do still have our appliance, but that's only for folks who really want a complete package solution. It's at the end of the day, when that's just an x86 storage server. So it's pretty much a software-defined story, and that's it.
Perfect. Thanks, Amit. So that concludes the questions for today. If you still have open questions, please reach out. And you can also find more information on our website, cloudian.com. And you can also email us at vsan@cloudian.com with any questions. And I would like to again thank both Tom and Amit for their time today and our audience for joining us. And we hope to catch you on the next one. Thank you, guys.
Thank you, everybody. Thanks.
Bye.
Thank you. Bye.